Assalamu alaikum dear students. In the series of learning C programming, we are discussing recursion in C. In the previous video, we have discussed types of recursion. In that video, we have discussed the tail and non-tail recursion. Everything regarding the tail and non-tail recursion have been discussed in the previous video very minutely. And in today's video, we are going to discuss one more problem based on the recursion. This problem is based on the non-tail recursion. This problem is the non-tail type of recursion. चूंकि अच्छी परा recursion CS मज पचमिस वीडियो में मुझे बुझासी recursion क्या गो, types of recursion क्या गो, direct recursion क्या गो, indirect recursion क्या गो, tail recursion क्या गो, तो non-tail recursion क्या गो. तो आज से ब्याका problem Backup program too. With the help of this program, we will discuss the flow of sequence of non-tail recursion. So first of all, here I have written a program, and initially here a function has been declared. The prototype of the function is that the name of the function is display and it is returning nothing. The display function is returning nothing, and the parameters that it is going to pass is integer type. After execution of this line, this is the function, display function. Why display int x? We know that the execution of the program starts from the main function. Obviously, the execution will start from this point. In this point, when execution will get started, a state memory, mainframe state memory will be allocated for this main function. For example, this is the main activation record. There is a memory space for activation record for this main memory, and for this main function. In this function, it has a local variable n is a local variable, and after execution of this line, the control will reach here. If we see here, n equal to display 10. This is a function call. We know that. It is a function call. Here, the display function has been called by the main function. That means display main is the calling function and display is the called function. And whatsoever the calling function will return back, called function will return, that will get stored in n. So here, display n. This function main is going to call a function by name display by passing 10 as the argument. Because main function calls a function is calling a function display, so the control will reach here. Why display? Obviously, a mainframe, a stack, a memory will be allocated for this display function as well. Display by passing 10 as an argument, that it is display 10. Display 10 has been passed to this by the main function to the display. 10 has been passed as an argument to the display function by this main function. So in the display function, there is also a local variable x, and this 10, which is going to be passed by main function, will be held by this x. Now the x contains 10, and after execution of this line, the control will reach here. This is a condition. If x less than 1, x, what's the value at present? The value of x is 10. 10 is not less than 1. We know that 10 is not less than. So this condition evaluates false. When this condition evaluates false, their statement after this if will not get executed. That means this return will not get executed. So the control will go to the else part. What is in here? Return 1 plus. Return. What will get returned? 1 Take care. What will get returned? It will get returned 1 plus 1 plus, take care, display x divided by 2. What is x? 10. 10 divided by 2 equal to 5. That means here it is also a function call. Take care. 1 plus display x divided by 5. That means another function. This is another function. Display is calling to display. The recursion. Direct recursion takes place here. This display function calls the display. That means that we know that the other function calls itself. We can say the other function is recursive in nature. So this is also a recursion function. Here is a direct recursion because the display calls the display directly without any dimension of any function. So here what will get display? It will call display 5 by passing 5 as an argument here. Now this x will contain 5. Okay? And then the condition will get if x less than 5, no, x is not less than 5. X is not less than. Here, this is the statement which has not yet been executed. 1. 1 has not been added. Only the function call is going here. And get executed. So, x equal to 5. This is false. Unless return 1 plus display, another function is going to be called what? By passing the argument 5 divided by 2, that is 2. Go second, another function, this is display 2 will get called by this display function. Display function called a display function. This is a recursion. Here, it has also a variable x. Now, x less than 1, x contains now 2 because with 2 has been passed as an argument. 2 is not less than 1, condition is false. So the control will go here. Return 1 plus display x divided by 2. 2 divided by 2 equal to 1. So this is also a function call. And again, display now at this time, display function has been called by display function by passing 1 as an argument. Here 1 is going to be passed as an argument. Now x contains, at this point, x contains 1. X less than 1, 1 is not less than 1, condition is false. So the control will go here. Return 1 plus display x divided by 2. 1 divided by 2 equal to 0. Because we know that 1 divided by 2 equal to 0.5. But we have declared x as an integer. So this will get discarded, the value will be 0. Now, display, here, 0 is going to be called by display 1 by passing argument. What is the argument? Now this x contains 0. This x contains 0. And after execution of this line, the control is reach here. If x less than 1, yes, here now. Because we are in this display 0 function. X less than 1, yes, x is less than 1. Now at this time, this condition, x less than 1 return is true. This condition evaluate is true. So the statement after this if condition will get executed. What is the statement? The statement is return. But why to return? The question is why to return? It will get returned where it has been called. Yet in the call icon, so it gets return. We know that return 0 has been called, but this return 0, it has been called by return display 0 here. What will get returned? 0. That means 1 plus 0. 1 plus 0 equal to 1. Because this display 0 returns 0. 1 was previously 1 has not been added. Only we have only called the display function. 1 was still there. 1 statement, 1 plus. It was yet to be executed. It was pending. We can say it was pending. So 1 plus 0 equal to 1. And again, it will go back in backwards. We know that recursion. First, it will go here. After that, this function was being called. This function has been called. This, and after this. And after fulfilling the condition, we can see the base condition, terminating condition, the control goes in the same process but in the backward direction. Here 2 1 plus display 1. What is going to be returned here? 1. That means 1 plus 1 is going to be 1 plus 1, because 1 is going to be returned. 1 plus 1 equal to 2. 1 plus 1 equal to 2, because this function returns 0. 0 plus 1 is now, and that is 1. 1 is going to return to this. 1 plus 1 equal to 2, and similarly display 1 return to display 2. What? 1 plus, now this display 2 equal to what is going to be returned by display 1? 2, and it will become obviously 1 plus 2 equal to 3, and this 1 plus 3 will be returned to display 5. That means 1 plus what is display 2 returns to this 3 equal to 4, and after this display function will return back here display 10. But actually this was display 10. What was going to be returned? Now this will return display 10 4. Now this 4 will get assigned to n. Now this n contains, what was n? It contains now 4. 1 0 plus 1 1 1 plus 1 plus 0 1 1 plus 1 2 2 plus 1 3 3. So 4 will get returned to this n. Now this n contains 4. This n contains 4. Printf %dn, and the output will be 4. This is the way, this is the sequence of operation. We can say the flow of execution of this recursive function, and it is also a tail recursion function. Why? How it is tail? Because we know that the tail recursion is that type of recursion in which after the recursive call nothing will be pending. There will be no statement yet to be executed. But here it is a recursive call. After the recursive call, one is still pending. So we can say it is an example of the non-tail recursion. I hope now that you have understood fully what is recursion, what are various types of recursion, direct recursion, indirect recursion, tail recursion, non-tail recursion, and also the program based on these types. And inshallah, in the next video, we will start one more concept of C, that is structures in C. And till next video, take care. Bye bye.